This is geometry. This video is meant for Grace, but I'm sure a lot of other people will get use out of this in the years to come. This is lesson 2-4 for geometry midpoints. The date of recording here is the 3rd of November 2023. Our objective today is to find a midpoint given two endpoints and to find a missing endpoint given an endpoint and a midpoint. So there's a bunch of ways that we can approach this problem, but I want to start with some vocab. What is an endpoint? Technically, an endpoint, I'll write this down, an endpoint is a point, maybe I'll do a colon here, colon. It's a point that is equidistant from two other points that is on a line. And when I say a line, I mean a straight line, not a curved line, connecting the 2 points. So I can draw a quick little picture here, but you guys can probably guess what I have for a midpoint. But if I have some sort of line, let's go ahead and say I have a line right, I want to make this a straight line though. If I have a line that ends here and ends here, we're going to call these things an endpoint. I'm going to call this thing an endpoint. Halfway in between, I'm just eyeballing here. It looks to be right about there. I'm going to call this thing the midpoint. If I were to connect these two lines with a line, you can see that the midpoint lies on that line, and this distance here is the same as that distance here. That's my definition. All right, so how do you actually find this thing? And I always start using geometry to help us with our definition, and then from there I derive a shortcut. So let me give you an example, and we'll hopefully learn from that example. So we're going to do example 1. I'll say find the midpoint. And let's go ahead and add in a graph here. Do I have a picture of a graph that I can add into GoodNotes? It looks like there's a graph I can add in. So to find the midpoint, I don't need a graph that's big. I can make it smaller. What if I give you something that looks like this? I'll give you a point right here at 2, 1, and I'll give us a point at 6, 5. So I want to find the point that is halfway in between these 2 points. Actually, let's make this slightly harder. I'll go 7, 5. This makes the problem a little bit harder. So if I connect the line between these 2 points, I need to find what is halfway in between here. And it's, I mean, I could eyeball and say it's somewhere right about there, but is it this point, this point, this point? I'm not exactly sure. And our way of solving this problem is we make a right triangle. We're going to go ahead and make a line down here, a line down here, and we're going to count. We say that this distance right here is 4, and this distance right here is 5.
Y'all trying to play.
And to find the midpoint, I need to have half of each of these dimensions. So half of 5 is 2.5, so 1, 2, and then a half. So I'm going to draw a temporary black line that goes up through here, and then I can say if I'm doing half of 4, that's going to be 2. I'm going to, from this point, I'm going to go down 2, 1, 2, or I can go from this point and go up 2. It doesn't really matter. And then I'm going to make a black line that goes through there. And we can see that that midpoint belongs right here. And then the answer to this would be, this point right here is 4.5 or 4.5, 3. So graphically, the way that we solve these is we make right triangles, and we take each dimension, the x and y dimension, take half of that and add it back on to the original amount. However, there is a shortcut here, and that is to look at the x and y coordinates. And let me annotate this too. So what I gave you was a point that was called 2, 1. And I also gave you a point up here that was called 7, 5. Let's write this down off to the side, and I think maybe the pattern will become clear. I had 2, 1, and I had 7, 5. Let me do parentheses around each of these. To find the midpoint, again, another way of saying midpoint, I can cross this off and I can say the average point. If I find the average of the x's and I find the average of the y's, then that will also be the average of the points. So what I'm going to do here is I'm going to find the average of 2 and 7, and the way that I do that is I just add them together. 2 plus 7 is 9, and I'm going to add 1 and 5 together. 1 plus 5 is 6, and I'm going to take each of them divided by the number of points that I added up. I have 2 points, so I'm going to divide each of these by 2, each of these by 2, and we get this answer that is 4.5 comma 3 for the average. And you can see that that does indeed match what we found all the way over here. This was found graphically. This was found just algebraically using the definition of the average. And this is usually the shortcut that we come up with. You just take the average of the point. So what I'm doing right here, and I'll write this down, this was the average of x and y coordinates, which essentially says you add them up and you divide them by 2. All right, so that should be able to solve the first problems. And if I take a peek at the homework, in the homework you're given this problem where you don't have a graph, which you just can take the average of 10 and negative 5, which you add them up. 10 plus negative 5 is 5, and then you divide by 2. So 5 divided by 2 is 2.5. So this answer is going to be 2 point. Here, let me write this down a little bit more explicitly, but you can say something like this. You can say 10 plus negative 5 for the x coordinate, and then we divide that by 2, comma, and the y coordinate is you do 10 plus 10, you add those up and divide by 2. That is the answer. I just need to simplify that. So when I simplify that, this is going to turn into 5 divided by 2, 5 divided by 2, comma, 20 divided by 2. And I can simplify that a little bit more. And I can say 5 divided by 2 is 2.5. And 20 divided by 2 is 10, which makes sense because the average of 10 and 10 is also 10. So our answer here would be 2.5 comma 10. Again, you're just finding the average in the points. And then we also know how to do, so that's problems 1 through 4, it's the same method. And problems 5 through 8, you're doing the triangle method because these are graphs. So you'll make a right triangle underneath each of these. And you'll say, okay, how far do we travel down here? We travel a total distance of 4, so go half that distance, go and travel 2. Over here we traveled 1, 2, 3, 4, 5, 6, 7, 8. So half of that will be 4, and 4 lives right here. And you can see that these meet up right here at this point, and then you write down the x and y coordinate. This is 1, comma 1. So you're using the right triangle method every time you see a graph. You're using the average method every time you see some points. But then you get to these last 4 problems. What happens if I give you an endpoint and a midpoint? Let's take some notes on that one because we don't have any notes for that one. Let's do example 2 down here. So for example 2, I also want to do this on a graph because I think we can derive a cool little trick from it. Let's just add another graph down here. It doesn't need to be so big. I want to also, we'll say, find the missing endpoint for my instructions. So find the missing endpoint. Let's go ahead and say, I'm just going to make up some numbers really quickly. And let's say we had 3 comma 5 as an endpoint. I'll label it E for endpoint. Let's go ahead and say we also had, let's go ahead and say negative 3 comma 1. This is the midpoint. And is this going to be too far off the, no, this is not going to be too far off the graph. So we need to find another endpoint. So if I connected these straight lines, the endpoint is going to be somewhere around here because the midpoint needs to be halfway in between. So somewhere in this area, I know I have an endpoint, but I need to figure out how. Normally I give you a lot of time to think about this, but because I'm by myself today and I only have a little bit of time to teach you, again, you start off by making a right triangle. So if I connect this red line, I could actually extend that red line all the way down here, but I'm not sure like what the slope should be. I don't know where this should be. I could try to make it look as straight as possible, but I might be off by a little bit. So I don't know what to do, but I am going to make this right triangle. So if I make this right triangle says I went down 4. So I'm going to say this length here is 4, and this is 1, 2, 3, 4, 5, 6. This length over here is 6. So all you have to do is you copy this same triangle down, and then that will make sure that we have the same slope. So if I copy this same triangle down, I want to go down 4. So 1, 2, 3, 4, and I'm going to go left 6. 1, 2, 3, 4, 5, 6. And then I'm going to go ahead and connect that with my red straight line. And I have 2 copies of the same triangle, 4 and 6, which means my final answer right here is my endpoint. and that endpoint has coordinates that are -9, -3. And the midpoint here was the coordinates -3, 1. And this endpoint that we were given has coordinates of 3, 5. So what happens if I just give you these coordinates? Because notice that in our homework, we aren't given a graph. We're only given the points. So is there a quick way to do this without without just having a graph? And the answer is yes, because look what's happening here. What I'm saying by having a 6 here is how much did I change to get from 3 to -3? I'm just looking at the x coordinates. How much did I change between 3 and -3? Well, I moved left 6. I went technically -6, which means I need another -6 down here. So I'll do an example on the homework. And then how did I get from... Oh, sorry, let me complete that thought. So if I went from 3 to -3 by subtracting 6, subtract 6 again to get from -3 to -9. I call that the leapfrog, if you're leaping and then leaping again. And then how do you get from 5 to 1? Well, I subtract 4. So technically I have a -4 over here. So from 5 to 1, you subtract 4. Well, we need to subtract 4 again. So 1 minus 4 is a -3. So you just keep continuing the pattern. So I will say, find the missing endpoint. And the problem was, if an endpoint was 3, 5, and the midpoint here was -3, 1, well, you do the leapfrog. To get from 3 to -3, we went down 6. That was a terrible 6. Down 6. So we go down 6 again, and I go -3 minus 6 is -9. And then to get from 5 to -1, we go -4. So we do -4 again, and we have 1 minus 4, and we get -3. So we get this answer of -9, -3 for our final answer. All right, so I think the notes are done. I'll print that out for everyone. But let's go ahead and apply that to one of these homework problems. Let's just choose number 9. So you always start at an endpoint. Notice that what we did in the notes, we started at an endpoint and then we went to the midpoint. You don't go the other way around, otherwise you're going to think the endpoint is going to be up here, which doesn't make sense. The endpoints should be on the other sides of the midpoint, on either side of the midpoint. So start at the midpoint, or start at the endpoint, and we're going to go to the midpoint. So this is how I'm going to show my work. I'm going to say from -2 to 7, we go up 9, plus 9, because we had to go up 2 to get to 0, and then up another 9 to get to, or up another 7 to get to 7. So that's a total distance of 9. And then how did we move from -3 to 0? Well, we had to go just up 3. So if I go up 3, I get to 0. Everything makes sense. And then we do this same pattern again. So if I went up 9 to get for x coordinates, I go up another 9. So I do up another 9, and 7 plus 9 is 16. To go up another 3, so I went up 3 to get to 0, and then go up another 3. So we'll say over here, go up another 3. 0 plus 3 is 3. And there's our final answer, and it's going to be 16, 3 in parentheses to show that it's a coordinate point, and box it. All right, so you've seen how to solve each of the 3 problems on the homework for free. You have the notes. That concludes lesson 2-4 on midpoints. Thanks for watching.